Okay, so up until now, we've learned a whole bunch of different methods. So we've learned how to find solutions by graphing, by factoring. We've learned about special factoring, which is difference of two squares in perfect square trinomials. We've learned about the square root method and completing the square. So today we're going to learn the final method, which is the quadratic formula. Now, the quadratic formula is kind of like I called it in class yesterday, I called it like the silver bullet. Because it works every single time. It's not always the fastest method, but it always will get you the correct answer. Okay. The other good thing about the quadratic formula is that it is on your formula chart. So if you freak out and you're like, I don't know how to factor, I don't know any of this stuff, you can at least find, well, you have to know how to factor, but if you don't know any other solution, you can always use the formula chart. It's on your formula chart, so you'll always have it. They'll always give it to you, okay? So we're going to start on this last part of our notes. The first thing I want to do, though, is I want to look at the back here, okay? So we're going to talk about the discriminant. And the discriminant is part of the quadratic formula. Well, it's a little portion of the quadratic formula. So when you look at the quadratic formula, it's negative b plus or minus the square root of b squared minus 4ac over 2a. Wow, that's a lot. The discriminant is this part right here under the radical sign. And the reason why I always do the discriminant first is because the discriminant is going to tell me how many solutions I have. And it's also going to tell me if I have no real solutions, I don't even need to continue. Okay, this negative b over 2a also tells us something, and actually it tells us the axis of symmetry. So if we want to find the axis of symmetry and all we have is one of these quadratic equations, we can use negative b over 2a to tell us what the axis of symmetry is. But we're going to be focusing on this part right here, the discriminant. We're going to do the whole thing, but we're going to talk about the discriminant first. So the discriminant tells us how many solutions we have. So if my discriminant, there's a space there, is, let's say my discriminant is negative. So if my discriminant is negative, then I have 0 real solutions. Okay? So if my discriminant is negative, then I have no real solutions. If my discriminant is 0, then I have 1 real solution. If my discriminant is positive, then I have 2 real solutions. So this looks just like a number line with 0 in the middle. The top looks like a number line with 0 in the middle. Negative, 0, positive. The bottom is 0, 1, 2. So if I have a negative discriminant, then I have no real solution. So it doesn't even matter. I don't need to keep going. If I have a 0 discriminant, that means I have 1 solution. If I have a positive discriminant, that means I have 2 solutions. So you're like, what does that even mean? So let's do a problem first, okay? So the first thing that we always do, so the first thing is, when I have one of these equations, in order for me to solve it using the quadratic formula, it must be set equal to 0. If it is not set equal to 0, I cannot use, well, I have to set it equal to 0 before I use the quadratic function. Quadratic formula. The cool thing about the quadratic formula is I don't have to get rid of my GCF. So I'm going to say we can keep our GCF. Okay? So because this is not a factoring method, I don't have to take out the GCF. I can use it just like I see it. Now none of these have a GCF, but if I had a problem that did have a GCF, I wouldn't have to worry about that GCF because with the quadratic formula, I use it just like I see it. Okay, so the first thing I'm going to do is, number 1, I make sure that it's set equal to 0, which it is. Okay, so I am set equal to 0, so this one is good to go. Now, I'm going to identify A, B, and C. What should I put in front of this one right here? Yeah, I should put a 1 there because I want to know what A, B, and C are. Remember, A, B, and C are just numbers. There's no letters after them. So A is not x squared. A is 1. B is negative 4. C is 1. Okay, so it's just the numbers. Okay, so the next thing I'm going to do is I'm going to find the discriminant. Okay, this is not a waste of my time because even if I find that the discriminant is a positive number, I can still plug that back in. So I'm going to start by finding b squared minus 4ac. Okay, so b squared minus 4ac. So I'm going to substitute every letter that I substitute, I'm going to put in parentheses. So I'm going to do negative 4 squared minus 4 times a times c. Okay, and then I'm going to use my calculator, and I'm going to put exactly that into my calculator. So exactly like I see it. I put that negative 4 in parentheses. It's going to be in parentheses. Squared minus 4, 1, 1. And I get 12. So that means since 12 is positive, that means I'm going to have two solutions to this equation. All right? So now I know that I can keep going with my quadratic formula. So I'm going to do negative b. Now notice, every time they give me a number, I put it in parentheses. So negative b is negative 4. So I do negative 4 plus or minus the square root of b squared minus 4ac. Well, didn't I already find that? Yeah, it's 12 over 2a, which is 1. So that's 4 plus or minus the square root of 12 over 2. Okay? So far, this looks very similar to the stuff we did with the square root method, right? So since I have plus and minus, that means I'm going to have 1 that's 4 plus the square root of 12 over 2, and I'm going to have 1 that's 4 minus the square root of 12 over 2. And then I'm literally just going to put that in my calculator. So I'm going to do alpha y equals to give me a fraction because I like to make it look as close as possible. 4 plus the square root of 12 over 2 gives me 3.73. Okay, and then for minus the square root of 2 over 2 gives me 0.267. 2.267, 7 is going to round me up to 0.27. So my solutions are x equals 3.73 and 0.27. Okay? Now, I could look at the graph if I want to confirm that. I could say x squared minus 4x, plus 1, and look at the graph. And when I look at the graph, I should see one right there at 0.27. That looks right. I see one at 1, 2, 3, almost to 4. So it looks like, from an estimate standpoint, it looks like I've got the right thing there.